In this session of laws of motion, we are going to discuss about the laws of dry friction, right? In the previous session, we have discussed about the frictional force and we have discussed about two types of frictional force. One is called the static frictional force and another one is called the kinetic friction force, right? We are going to revise the types of frictional force between two solid surfaces in contact. As we have discussed in the previous session, there are two types of frictional force. One is called the static frictional force, and static frictional force will arise due to the tendency of relative motion or possibility of motion of solid surfaces in contact. The tendency of relative motion or possibility of relative motion of solid surfaces in contact will arise when a force is applied on the body but the body is not moving. Now there are another type of frictional force which is known as kinetic friction force, and this kinetic friction force will arise due to the relative motion of the block on the table or due to the relative motion of solid surfaces in contact, right? Do a very simple experiment. Take any type of heavier object. This heavier object can be treated as the block, right? Place this object on the horizontal surface or the table. Now initially the heavier object or block is placed on the table without the application of any external force, right? In that situation, the block do not have any tendency of relative motion or the block do not have any motion on the table. That's why the frictional force acting on the block will be zero. Now you are going to apply an external force F. Due to the application of external force F, the tendency of motion or the possibility of motion of the block will develop towards right. Due to this, the frictional force will arise at the point of contact towards left. Now, by increasing the force F, after some magnitude of applied force F, the block will start the motion on the table. In that situation, the frictional force will act and the nature of the frictional force will be the kinetic friction, and that kinetic friction force will act towards left. Now we are going to draw the free body diagram of this block. There are various forces will be applied on this block by the surrounding. One by one you can see that force. First force will be the external force applied by the external agent. The next force will be applied by the table, and this force is known as normal reaction, and this force will act vertical upward. Now the next force will be applied by the table, that is the frictional force, and it will act towards left because this block will have the tendency of motion towards right due to the application of this external force, or the block has the motion towards right. Due to this, the frictional force will act towards left. Now the next force will be the gravitational force, which will be acted by the earth, and this gravitational force will be the weight of the block that will act vertical downward. When the block is not moving but the block has the tendency of motion due to the application of the external force F, then this friction force is known as static friction, and in that situation the block will have the zero acceleration. By Newton's second law, that means the applied force F minus the frictional force F will be the net force, as the acceleration of the block will be zero in the situation of the static friction because the block is at rest. In that situation, F minus F will be equal to 0, and hence the static friction force will be equal to the applied force capital F, right? Now when the block will have the motion, in that situation the kinetic friction force will act. The block can have the acceleration and that acceleration can be calculated. Now you are applying Newton's second law. According to Newton's second law, the net external force will be equal to applied force F minus kinetic friction force. This net force will be equal to mass into acceleration, right? Now the most important is that you can see this graph when you have not applied any force. That means when the block do not have any tendency of relative motion or do not have any motion on the horizontal surface, then in that situation the frictional force will be equal to 0. As you increase the applied force F, then the frictional force will increase, and this frictional force will have the nature of static frictional force, and this frictional force will be equal to the applied force F. Hence, the graph will be the linear. You can see when you have applied a force of 10 Newton, then in that situation the frictional force will be 10 Newton because the block is not moving. When you have applied a force of 20 Newton, then in that situation the frictional force will be 20 Newton. At the value of 30 Newton, the frictional force is 30 Newton. Hence, the block is at rest up to the application of applied force just below 40 Newton. What you can see, just below 40 Newton force, the static friction force will have the maximum value, and this static friction force is called a limiting static frictional force, right? If you apply the force just above the force of 40 Newton, then what you can see, the relative motion of the block will start. Then after that, the kinetic friction force will act on the block, right? What you can observe, the value of kinetic friction force will remain constant even if you will increase the value of the applied force. Hence, from this experiment, one main point can be observed that static frictional force is variable and it will be equal to the applied force, but the kinetic friction force will be independent of the applied force. That means once the motion will start, then the kinetic friction force will be constant. It will not depend upon the applied force, right? Now the next point is that the maximum value of the static friction is called the limiting static friction force, right? Now, on the basis of this experiment performed on this block, we can deduce certain points, and that points will be the laws of friction. Now, on the basis of the experiment performed, we can define certain law of friction between two solid surfaces in contact. The first law is that static friction force equals to the magnitude of the applied force parallel to the surface that you have observed. Second one is the value of static friction force will have certain maximum value, and this certain maximum value of static friction force is known as limiting static friction force. Now, this limiting static friction force will be proportional to the normal reaction. Now consider the ABD of this block. What you can see, the forces which are applied on this block will be the applied force F, normal reaction R, frictional force F, and the weight mg. The value of limiting static friction force is directly proportional to the normal reaction R. This normal reaction R will be acted on the block by the surface in contact. Hence, the limiting static friction force will be proportional to the normal reaction. Hence, this limiting static friction force will be equal to some constant into normal reaction. This some constant is known as coefficient of limiting static friction or coefficient of static friction. This mu s is known as coefficient of limiting static friction or coefficient of static friction, right? Now the next point is that third point will be static friction force will be less than or equal to the limiting static friction force, right? The static friction force, this static friction force will have the certain maximum value. At that certain maximum value will be the limiting static friction force. Hence, in general, we can say that the value of static friction force will be less than or equal to the limiting static friction force, right? From these 3 points, one can deduce an important point, which will be the block will be at rest on the table until the frictional force acting on the block will be the static friction, and the value of static friction will have certain maximum value. This maximum value is known as limiting static friction force, and this limiting static friction force will be equal to mu s into r, where mu s is the coefficient of static friction or coefficient of limiting static friction, and r is the normal reaction acted by the surface in contact on the table. right? Now the next law is for the kinetic frictional force. The kinetic frictional force is also proportional to the normal reaction acted on this block by the table or by the surface in contact. Hence, the kinetic friction force is proportional to the normal reaction. This kinetic friction force will be equal to some constant into normal reaction. This some constant is known as coefficient of kinetic friction. This constant is known as mu k. Hence, Fk, kinetic friction force, will be equal to mu k into R, and this mu k is known as coefficient of kinetic friction, right? Now the next point is that in general, what you can observe, kinetic friction force is less than limiting static friction force. Next one is the static friction force and kinetic friction force both does not depend upon the area of contact between the surfaces, between the solid surfaces, right? And the next point is that the value of the kinetic friction force does not depend upon the velocity of this object. That means the value of kinetic friction force is independent of the sliding velocity. If this block will move with velocity 1 meter per second, or with 2 meter per second, or with 3 meter per second, the value of kinetic friction acted on this block by the surface in contact will remain same. It does not depend upon the value of the velocity of this block, right? These are the laws of friction that we have discussed. Now we are going to revise the main concepts of this session. First point or first concept is that there are two types of friction force. One is called the static friction force, another one is called the kinetic friction force. The maximum value of the static friction force is known as limiting static friction force. Next concept is that the limiting static friction force will be equal to Fs will be equal to mu s into R, and the value of the kinetic friction force will be equal to mu k into R, where R is the normal reaction acting on the object on which the friction force will be applied by the surface in contact.